Vertical farming, it honestly feels like something straight out of science fiction, right? I mean, just picture stacks of lush green plants growing under these neon lights, completely sheltered from all the chaotic weather and nasty pests of the outside world. But here's the thing. Behind those futuristic LEDs lies this highly sophisticated, totally invisible shield of engineering. So, in today's explainer, we're going to dive right in and explore the deep structural protocols that actually prevent microscopic disasters in controlled environment agriculture. Let's get into it.
Now, we naturally kind of assume that growing crops indoors completely isolates them from nature's dangers. I mean, it's a perfectly sterile bubble, right? Well, that's actually a super common misconception. Just because these facilities are sealed off from soil-borne pathogens and, unpredictable weather, it's so easy to think they're automatically risk-free. But as the source material for our explainer today makes crystal clear, controlled absolutely does not equal risk-free.
And honestly, you just have to look at the news. When headlines suddenly start warning us about E. coli and salmonella linked to packaged salads, it becomes absolutely crucial to understand why even these high-tech indoor facilities aren't totally immune. Just one tiny lapse in a facility's protocol, that can lead to massive recalls, completely destroyed consumer trust, and obviously severe health consequences. So how exactly does a modern vertical farm actually protect our food from these microscopic invaders?
Let's look at Section 1, Hidden Pathways of Contamination.
So out in the indoor farming world, threats still exist, and they fall into three main buckets. First up, you've got your biological threats. Think salmonella, E. coli, fungi, that sort of thing. Second, chemical contaminants. This could be pesticide residues, aggressive cleaning agents, or even heavy metals. And third, physical contaminants, like a random stray plastic fragment or a metal shaving from a machine. Now, you're probably sitting there wondering, how on earth do these get inside a hermetically sealed building? Well, they sneak in through completely normal, everyday pathways. The incoming water sources, the nutrient solutions feeding the plants, the seeds themselves, airborne particles, or simply through human handling during harvesting and maintenance.
And here's where it gets tricky. Because vertical farms are just so incredibly dense and interconnected, if a pathogen does manage to get inside, it can spread like wildfire, way faster than it ever would out in an open field. I mean, just think about how tightly packed that machinery and those plant canopies are. A vertical farm is essentially a closed-loop system. Now, while that is absolutely amazing for recycling water and nutrients, it also means that if an introduced contaminant gets in, it has the perfect transit system to distribute itself rapidly throughout the entire crop. It's a real double-edged sword, and it requires intense, round-the-clock vigilance.
Moving on to Section 2, Global Rules and Regulations.
To fight back against these rapid threats, indoor farms don't just wing it. They adopt some seriously rigorous standards that were actually originally designed for conventional agriculture, like Global GAP and HACCP. And listen, these aren't just fancy alphabet soup acronyms slapped on a package. HACCP, for example, stands for Hazard Analysis Critical Control Point. It's basically a super systematic approach to figuring out exactly where a physical, chemical, or biological hazard could pop up in the facility, and then embedding proactive controls directly into those specific operational points.
They also rely on universal systems like ISO 22000 to manage the whole food safety shebang. But hey, here's a pretty surprising fact for you. As this industry matures, the standard regulators are actually having to catch up to the specific, unique nuances of indoor farming. In places like Japan, specialized certifications, like one called JS0012, have been created completely exclusively for vertical farming. It was literally the first certification system in the world built from the ground up just for these high-tech indoor environments, which is pretty cool.
Next up is Section 3, Designing for Hygienic Zoning.
So this is where it gets really architectural. Much like a high-tech hospital clean room, these massive facilities are divided into incredibly strict zones. You've got low, medium, and high-risk areas, and they are separated by actual physical barriers to stop cross-contamination dead in its tracks. You can kind of think of them as color-coded areas. Low risk is usually your green zone, medium risk is the orange zone, and high risk is the red zone. You can't just casually stroll from a green zone into a red zone on your coffee break. The architecture of the building literally forces you to follow strict safety protocols just to move through the space.
Now, this next part sounds a bit counterintuitive at first, but the airflow inside is actually engineered to move in the exact opposite direction of the cleanliness flow. What engineers do is use positive air pressure in the absolute cleanest, highest risk rooms. So this means the air pressure in that red zone is physically higher than in the orange or green zones. Why? Well, when a door opens, that clean, high-pressure air constantly rushes outward, physically pushing any invisible airborne particulates, rogue spores, and basically just bad air away from the most vulnerable crops. It's brilliant. Let's walk through a day in the life of a seed across these zones. It starts its journey in the low-risk areas where seeds are sown into trays. At this point, the product isn't really exposed yet, right? So natural ventilation is totally fine. Then it graduates into the medium-risk rooms where the plants are actively growing. Ultimately, it gets processed and packaged in those high-risk zones. And why high risk? Because at this stage, those leafy greens are officially categorized as ready to eat. Since most of us aren't going to wash these prepackaged greens again at home, this red zone demands incredibly strict air filtration and extreme top-tier sanitation.
And to actually physically enforce this zoning, the whole factory layout relies on dedicated transfer zones. These are mandatory physical checkpoints, complete with strict sanitization routines. Think of it like going through security at the airport, but for hygiene. Before an employee can even cross from an uncontrolled area into a low or medium risk zone, they might have to completely change their shoes, scrub their hands, put on a dedicated smock, and don a hairnet. It's an unavoidable physical checkpoint built into the floor plan.
Take tray washing machines, for example. In the grand journey of sowing, growing, and harvesting, these washers have to be isolated in entirely separate rooms. Why? Well, after the harvest, cleaning those empty plastic grow trays involves some seriously high-pressure water spray. And that spray flings massive amounts of heavy, contaminated moisture right up into the air. If that washing station were just sitting next to the packaging line, yeah, you'd have an absolute disaster on your hands. So it is structurally walled off, complete with its own totally separate air extraction system.
All right, that brings us to Section 4, the reality of food safety.
So what's the big takeaway here? Food safety isn't just a final box you check right before packaging. It is a massive, comprehensive, living system that's woven into the very fabric of the farm itself. We're talking everything from sanitizing the seeds before they even hit the growing medium, to those precise positive pressure airflow systems, to exhaustive traceability and record keeping. Because, let's be real, if a contamination event ever does happen, traceability ensures the farm can immediately pinpoint exactly which batch is affected and pull it long before it ever has a chance to reach your grocery store shelf.
There's a great quote from the source material that really hits the nail on the head. 100% food safety is an aspiration. Strive for excellence, not perfection. Because biological systems are just so inherently complex, guaranteeing absolute 100% perfection, it's pretty much impossible. There are way too many variables, and, human error is always going to be a factor. But minimizing those risks through relentless, ongoing excellence, that is highly achievable. Food safety is a mindset of continuous vigilance, not some fixed destination you just magically arrive at and forget about.
So the next time you're at the store and you pick up a crisp, perfect box of indoor-grown greens, take a quick second to appreciate the totally invisible shields of engineering that brought it safely to your table. It really makes you wonder, if this much intense, calculated engineering goes into protecting a single leaf of lettuce, how might these high-tech safeguards completely redefine the entire future of our global food supply? Something to chew on.